Hello students, we are now going to start polymers. In this particular video, we will discuss about few basic introductory part on polymers and classification of polymers. See, there is a very famous statement that polymers are macromolecules, but macromolecules are not polymers. We have to use and we have to add two words over here, all polymers are macromolecules, but all macromolecules are not polymers. This is one of the important thing that counts. Now first of all, we would know the difference between macromolecules and polymers. Both macromolecules and polymers are giant molecules, very large, very big, but the only difference is in polymers, if you look structurally, one particular type of chain or a group keeps on repeating thousands and thousands of times. This repetition helps it to be defined as polymers. But in macromolecules, there is nothing like repetition. It is never repeated completely, and therefore it is never a polymer. But it is a macromolecule. But polymer being large can be called macro, and it's a molecule, therefore molecule. So all polymers are large and they have a specialized section which keeps on repeating. Therefore, they can be called both polymers and macromolecules. Macromolecules are large and therefore we call them macromolecules, but they do not have that particular part repeating constantly, and henceforth we can't call them as polymers always. So, what should we use the word for that part constantly repeating? We can use the word repeating unit for that part which keeps on repeating. Now, this polymer word has two different meaning. Poly means many and mer means molecule. Many molecules when combined together, they result in the formation of polymer. Many molecules when combined together, they result in the form of polymer. So many small molecules. So the repeating unit is that part which keeps on repeating constantly. Keep this thing in mind. Now, polymer is made up of several units that keep on repeating, and these units are called monomers. So we'll first just go through this definition which is mentioned over here. The word polymer is coined from two Greek words poly and mers, which means unit or part. The term polymer is defined as a very large molecule having high molecular mass and are also referred to as macromolecules, which are formed by joining of repeating structural units on a large scale. The repeating structural units are derived from simple and reactive molecules which are called monomers and are linked to each other through different bonds or covalent bonds. So friends, those smaller parts we keep on joining and form a long chain is called monomer. That long chain is called a polymer, and this phenomena of joining the small parts into this large macromolecule sized is called a polymer. So first of all, be sure about three things: monomer, polymer, and polymerization. Monomer, polymer, and polymerization. Now coming to a very important topic, that is classification of polymerization. In your reference book, if you go through, they have no doubt mentioned the classification, but that classification has some points not mentioned clearly. So we will just go through a basic classification first. You need to look on the screen very well. When I say that we are classifying polymer, it is classified on several different bases. of which the first base is the source from which it is generated. And when we talk about the source from where it is generated, it is again divided into three: natural polymer, synthetic polymer, and semi-synthetic polymer. When I say natural polymer, these are those polymers which are found in plants, animals, totally in nature. So the polymers that are obtained from nature are called natural polymers. And if you try and think, you will get very known examples like starch. You will also get rubber, which we generally call as latex. You have cellulose. You have a bit of what you say the pure silk. These are all polymers. There are several proteins. So these are all naturally obtained and henceforth are coined as natural polymers. Moving a step ahead, when you are classifying polymer on the basis of its sources, the second important class over here is a semi-synthetic polymer and a synthetic polymer. Let us go with synthetic polymer. A polymer that is prepared in the industry by chemical process is called a synthetic polymer. A variety of synthetic polymer as plastic fibers, synthetic fibers are all man-made polymers, means those are prepared in laboratory, industry, factories and are purely chemical based or purely synthesized, not obtained from nature. They are called synthetic. You have nylon, you have terylene, you have PVC, you have melamine dishes. These all are synthetic polymers. When we say semi-synthetic polymers, the naturally obtained polymer are sometimes passed through chemical process to increase some of its properties, like its tensile strength, its lustrous property, its hardness, its softness. So when these kind of properties are to be altered in a naturally obtained polymer through a chemical process, we call them as semi-synthetic polymers. So this is how we segregate or we differentiate a natural polymer, a synthetic polymer, and a semi-synthetic polymer. For example, in this semi-synthetic polymer, if I have cellulose and I undergo nitration or I undergo acetylation, I can write cellulose acetate or cellulose nitrate. This is how it works. So friends, this is important. Classifying polymer on its first base, and that base was the sources from which it has been generated. So the sources from where it has been generated includes natural sources, you have synthetic sources, and you have semi-synthetic sources. Going ahead in the same streamline, we will be classifying these polymers into some other parts and other bases. So the second base that we are going to see over here is the type of polymerization reaction. What type of reaction is undertaken for the preparation of polymer? It is divided majorly into two. One is the addition, second one is the condensation. So these are the two major types: addition polymerization or addition polymers and condensation polymers. See, this is also further classified, which we are going to learn because we have to also appear for the competitive exams. Addition polymers and condensation polymers, first of all, learn why they are differentiated from each other. It is dependent on the type of reaction. Addition reaction, when two or more than two same or different monomer combine with each other, the pi bond break and a new sigma bond is formed. Pi bond breaks and a sigma bond is formed. For example, if I have a monomer called ethene, then I'll combine one monomer of ethene with another monomer of ethene and a long chain like this. it always results into a very long polymer called polythene. But over here, this pi bond and this pi bond will break, and a bond over here will form, similarly outside and outside. So I will have something like this forming a long chain. So this is an addition polymer, only a breaking of pi and a forming of sigma. Over here, I can also take such examples. I will take a ethene. Along with ethene, I will try to take something else, some other molecule. For example, over here, if I am interested, let us take a different molecule which is more important over here. I will not take this example, I will just make a different example like this. Let us have a molecule of styrene, that is benzene ring CH double bond CH2, and I will combine it with butadiene. Now what is butadiene? I am just making a little tilt. It is something like this. We will go into detailed reactions later on, but if you see just over here, both the monomers that were reacting together and forming a new polymer, both monomers were same. So when both the monomers are same, you call them as homopolymers. Homopolymers. And what is the phenomena they are using? Addition reaction. Sorry, addition reactions. So they are addition homopolymers. Remember this very well. They are addition homopolymers. Why we coined them as addition homopolymers? Because over here, these particular polymer that was formed because of a reaction of two monomers, and both the monomers came from a same type. There was no difference in their type. Therefore, we call them as homopolymers. And the phenomena was addition. So, homo addition polymers. I think you are getting what I am saying. Let us move a step ahead. If you look to the example that I was trying to explain you at the bottom, where we had two different monomers. If you look into it properly, one is this monomer, second one is this monomer. I'm going into detail later on, but these two monomers are different. And when two different monomers combine with each other to form a polymer, from pi bond breaking and sigma bond making, we call it addition polymers, but two different monomers. So instead of using the word homo addition polymers, we will use the word co-addition polymers. So these are co-addition, these are homo addition. So addition copolymers and addition homopolymers is with one basic type. While going for the second type, that is condensation, you can combine two similar monomers together and form a long chain. You will call them as homocondensation polymers. But when you combine two different monomers and form a long chain, you will call it as co-condensation polymers. So this is very simple. When you have two similar monomers, homo. When you have two different monomers, co. When combining, they will only break a pi bond and form a sigma bond, addition polymers. But what about this condensation polymers? So while thinking of condensation polymers, while two monomer A plus A similar or A plus B different, combined together, they will either remove a water molecule or remove the ammonia molecule or remove the acid molecule, and they will form a product. They will form a polymer. And these type of polymers are called condensation polymers. And in that also two, homocondensation polymers and co-condensation polymers. So this is the basic difference. Remember it very well that when two monomers of similar type combine together by only pi bond breaking and sigma bond making, it is called homo addition polymer. When two different monomer combine together by pi bond breaking and sigma bond making, it is co-addition polymers. But when two similar monomer combine together and they remove a molecule of water, ammonia, alcohol, etc., it's a homocondensation polymer. And when two different monomer combine together and form a polymer by removing of water, ammonia, acid, etc., it is co-condensation polymer. So we had only two types. Type 1 is source, where we had natural, synthetic and semi-synthetic. Type 2 was method or mechanism, and over here we divided it into two. One was addition, second was condensation. When we explain addition, it is pi breaking, sigma making, same type of monomers join together, break pi, make sigma. We call it homoaddition. When different type of monomers combine together, break pi, make sigma, we call them co-condensation. Sorry, co-addition. But when two monomer combine and remove a molecule of water, acid, sometimes even alcohol, ammonia, we call them condensation polymers. When these two monomers are same, we call them homo. When these two monomers are different, we call them co. So this is how the classification is based on the second, that is type of polymerization reactions. These details are going to come later on. Just now we are only focusing on the, what you say, the mechanism on which they are prepared. So please be alert. The third type, which is not given in your book but is very important, is type of polymer formed. There are three type of polymer formed. One is chain polymer, second one is branched polymer, and the third one is cross linked polymer. Remember very well: chain polymer, branched polymer, and cross linked polymer. So this is the third type of polymer formed, or rather to say, you can say on the basis of its structure. On the basis of its structure. On the basis of its structure, they are again into three: chain polymer, branched polymer, or cross-linked polymer. When can we define it as a chain polymer? Keep your eye on the screen. This is the third main part. First, chain. When you have monomer just in a chain, they can be of same time, can be of different type. That is not a question, but it should be a repeating unit. Simple chain, you always will coin them as chain polymers. But sometimes along with this chain, you have branch, that is A, B, A, B, A, B, C, C, C. It is branched polymers. It has branches. But when I say a totally different thing, cross-linked polymers. Cross-linked polymers. Over here, A, 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 B, 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 B. So this is a long chain. There will be a second long chain. These will be linked from somewhere in between. This will continue better. See what is happening. They are linked somewhere in between. It is not branch. They are interlinked with one another. This chain is interlinked with this chain, is interlinked with this chain, is interlinked with this chain. So this interlinking result into cross link. So these are the three different ways by which you can classify the polymers. There is one more method, but it is going to come along with the theory. First one we did was on the basis of the source, natural, synthetic and semi-synthetic. Second one was on the basis of its mechanism, majorly into addition and condensation, followed by homo and co, homo and co. And the third one was on the basis of the structure, that is linear, that is chain. Chain can also be written as linear. Mind well, remember, chain can also be written as linear. You have branched and you have cross-linked. So this is a very short explanation on classification of polymers. In the coming video, the next one, we will be going on in detail with different polymers and their detailed explanation. So let us keep it as such. You just go through it. If you have any queries, you can contact me. In the upcoming video, we'll go with the details of polymers. This was just an introduction to polymers. Thank you.